He kōna I purangi tēnei nā te reo irirangi o Aotearoa.
Did you know that rats giggle when they're happy?
Yeah, so this has actually been known for quite some time.
We just can't hear them.
The ultrasonic vocalizations are about 50 kilohertz or 50,000 hertz vocalizations, well above the range of human hearing.
And these ultrasonic giggles have been well linked to rat joy.
They do these when they're being extremely sociable or often when they're getting tickled by humans, in fact. So when they're getting a pleasurable experience, the equivalent of a belly rub.
Kia ora, nau mai haere mai ki te ao hurihanga. Hello and welcome to Our Changing World, ko Claire Cannon tēnei. Today we're talking animal emotions with Professor Ximena Nelson from the University of Canterbury. Ximena studies animal behaviour and physiology.
I work in, I guess, quite a diversity of areas, ranging generally in the discipline of behavioural ecology, but I work with insects in some cases, jumping spiders quite a lot, and kea.
A lot of her research with jumping spiders is looking at visual information processing and decision-making. But with kea, she's interested in emotions.
Recently, I've been working on the idea of emotions in non-human animals, specifically in kea, although I collaborate with people who work on primates and on cetaceans as well. And we are trying to investigate how to look at emotions, how to measure emotions, specifically positive emotions. Negative emotions are slightly easier to measure because an animal like a dog might yelp. But positive emotions are a little bit harder to disambiguate. And so we're trying to find a way of measuring that and then finding, once we can reliably measure that, trying to work out if these emotions, these positive emotions, if the animals do in fact have them, if they affect, for example, decision-making or sociability or other aspects of the behaviour of the animal as they do in humans.
Think about how tricky this is to actually study. First, how can you tell if an animal is joyful or happy? You can't ask them. And second, how can you test whether that mood impacts their decision-making? First things first, spotting joy. I mean, my mind immediately goes to dogs. Their emotions can be so easy to read. But Ximena cautions that they're quite a special case.
It is quite hard to, in some ways, to extrapolate from animals that have been what you might almost call co-domesticated, where humans and dogs have almost domesticated each other. So we know how to read dogs, dogs know how to read us and equally manipulate us. So it's quite hard to extrapolate from an animal from which we've had thousands, tens of thousands of years living together and cohabiting together to an animal that is rather different. First of all, that is not a domestic animal. And also, for example, in the case of kea, I mean, the musculature of the face is completely different to that of mammals. And so, whereas mammals might be thought of as, in some cases, capable of smiling in all primates, and often you hear that referred to in dogs as well, in a bird it simply couldn't happen because they just don't have the correct muscles to be able to do something like have a crinkly eye or whatever might give away a classic smile. And I'd also say that actually in humans, I mean, we tend to think, okay, a smile is supposedly kind of an indicator of a positive emotion, but there are smiles and there are smiles. So it can actually be surprisingly difficult to determine whether or not that's a real smile, a fake smile, a nervous smile, or the various other forms of smiles that there are. But there is such a thing as a real smile in humans that does cross cultures.
So you can't look for smiles or crinkly eyes. And, as with the case for the rats, happy animals might even be giving off signals that we just can't sense.
There's all sorts of other things that we don't even think of that animals might be using as a sensory system because we don't even have that sensory system, or at least we don't perceive that we have that sensory system. You know, there's magnetoreception, there's electroreception, there's infrasound below the range of human hearing. There's, ability to see in ultraviolet, all sorts of things that we don't have the ability to do. And so, it does take thinking outside the box to work out, well, is it because there's nothing there, or is it because I just don't perceive it to be there? And that's quite aside from the problems of it not being able to answer you a direct question, are you feeling happy or whatever.
So I guess step one is presuming that animals can have positive emotions and then looking for what their tells might be. For Ximena, the idea for this research was sparked by her own observations of kea in the wild.
Kea are famously playful, and I spend a lot of time in the mountains. And I'd seen them doing a lot of pretty interesting play behavior, including play behavior is something that is often considered to be some sort of, kind of outward expression of joy. But on the other hand, you could also equally argue that play is a way of practicing skills like, hand-eye coordination or paw-eye coordination in the case of a dog or a cat with a piece of yarn, or hunting skills or things like this. So you can be practicing, or in the case of humans, social skills. Imagine a toddler when, the toy has gone the wrong way around and all hell breaks loose, right? So you've got to learn the tit-for-tat approaches to play, and that teaches humans and other primates social skills. So there are lots of functions to play, but what I've seen in kea is often play that really defies any kind of functional logic. For example, I've seen kea fly to the top, kind of the apex of a roof, and this is in the winter, snowy roof, and literally just get on their backs and slide down the powdered snow until they fall off, the roof onto the bank of snow below. And okay, the first thing you might argue is, well, that's a very unusual way of getting from A to B. But then the kea flies up to the top of the roof again and does it again, in which case it clearly wasn't trying to get from A to B on its back. And on top of that, the kea did not go to any place on the roof. It actually slid down the part of the roof that had already compressed the snow, that it had already slid down, which, being somebody who likes snow, I know perfectly well how much that speeds up the process, right? So it seems like this kea was doing something purely for the fun of it, and there's no obvious functional kind of reason for it. It's not like it's hunting or trying to find food. It's not getting from A to B. There's no skill that a parrot might need involved in that. So it begs the question: what is this just having fun? And it repeated it over and over. And again, that's another repetition is another kind of aspect of play. And so you start thinking, well, it might be quite fun. And then on the other hand, anybody that's seen kea in the rain, it's quite easy to anthropomorphize and to go, God, they look pretty miserable. They've got their hackles or the feathers around the back of their neck raised. They're sitting in a tree, face looking down, looking to all human extents and purposes pretty morose and not really tossing pebbles or doing anything like that.
Famously playful indeed. I think most people have seen the GoPro footage from the Kepler track last year when an inquisitive kea took the camera for a fly round. I also had an experience with them last summer, waiting for the light to change at the Homer Tunnel in Milford. My mum and I had just gone kayaking in Milford Sound, and the kea delighted in hopping from kayak to kayak, pecking at the straps as I did laps of the car, waving my hands. I must have been great entertainment for the car behind. Anyway, starting with this premise that kea do experience positive emotions and are playful and joyful, the next question is, how do you identify the markers of this? What does kea joy look like?
I then started looking at kea communication, because at the time, really, we kind of only thought that kea had the one call, which everybody knows, and I won't try and imitate it because I'm terrible at it, especially under pressure with a microphone here.
It's okay, insert audio clip of
yeah,
kea
insert
here.
audio clip. So the screech call or the kea contact call, but anybody who's been around kea knows, and anybody who actually knows the first thing about birds knows that it's pretty unlikely that they would have one type of call. So I decided to just try and work out, what kind of calls I had, how many calls I had, and specifically if the calls had any given function. And so I had a PhD student, Raoul Schwing, who worked on that at the time, some time ago now. And we got recordings of quite a number of calls, but 7 calls that we could sort of classify as very clearly separate calls. And we tried to work out what the animal was doing at the time that it called, and also the ramifications on any other kea that were around. So did it elicit some kind of, look for food, or there's a predator, hide, or something like that. So any kind of functional referent is what we would call that. And so we started doing all these experiments and, first of all, just amassing a huge database of the calls and the behavior of the caller and the receiver of the calls, and found actually that it's not that straightforward. That calls aren't necessarily associated very clearly or specifically with one type of behavior. That many calls are attributable to lots of types of behavior. But one call that did stand out was what we call a warble call, which is often termed Kia laughter. And that was a call that was associated very, very frequently with play and with almost nothing else. And it elicited, so when an animal or a Kia did a warble call, it seemed to elicit playful behavior in the Kia that were around it. So then the idea was, okay, well, we have to actually experimentally manipulate this, test this. So we did some playback experiments with Kia-proof speakers, which is a lot easier said than done.
Talk to me about what a Kia-proof speaker involves.
Actually, I've got it right there inside that bag. And it's been a while since this has come out of the bag. So it's basically half of a Pelican box, which has got a speaker in it, which has got a remote operated control and some fairly hardcore chicken wire with some nylon rope. And the chicken wire has been replaced, as you can probably see, quite a few times. And then this was hidden behind a rock and constantly monitored by the person who was testing, who was also hidden behind a rock. Because we tried various iterations of speakers that we could use for playback. And of course, they didn't last very long at all with the Kia.
How many speakers did you go through?
Oh, God, I can't remember. But a number, a good 3 or 4.
So how the experiment worked is that Ximena and her team would head to a location near Arthur's Pass where they know Kia tend to hang out. Once some Kia showed up, they would play some sounds.
The warble call?
A pure tone of 1,000 hertz, which is in the same frequency band as Kia calls and hearing.
South Island Robin territorial call.
In 2 of the other Kia calls, the screech or contact call,
and the whistle call, which is a kind of a sweet call, really. It sounds like a whistle.
So the experimenter and speaker are hidden at a distance away from the Kia, and then the research begins.
We looked at the behavior of the bird for 5 minutes before the playback, for the duration of the playback, which was discontinuous. So we had a few seconds of call, a few seconds off, a few seconds on, because you can't have a very annoying, 60 seconds of call. That would just cause consternation. And then for the next 5 minutes, we looked at the behavior, and then we just scored the behavior before and after in 1 minute bins, so the behavior per minute, and then averaged what behavior, how much time, for example, they spent playing before the call, how much time they spent playing during that minute of calling, intermittent calling, and how much time they spent playing after, on an average per minute basis.
And what did you find?
And we found that they did not change their play behavior at all with any of the other calls, bar the warble call, and that the warble call did increase both the time that they spent playing and the number of separate play bouts that they exhibited.
Which is pretty cool. You're just playing a sound, which is, we're kind of thinking it as Kia laughter. We can't really know what it's like to be in the brain of a Kia, but if we think of it like that, you're just playing some laughter and they feel more joyous. Again, we're not in their brains, but they're playing more.
That's right. So we kind of concluded that it was an emotional contagion because we did see that it would elicit, in a multitude of birds, it would elicit the same spontaneous kind of playing. In much the same way as in humans, we use canned laughter on radio and on TV to essentially, get people in the audience to engage with the material in a positive way.
Feel more joyous? This research into warble calls that Ximena and her team did was quite some time ago now. What's the next stage that they've been working on?
We can at least conclude the contagion part, but we want to know whether or not it's a truly kind of a feeling of joy, if you like. And so there are a few things that we want to do. Is first of all, we just want to see what the correlates of feeling potentially joyous, for lack of a better word, is. So in humans, a sunny day, particularly after, like lots of horrible weather, a sunny day, you kind of wake up going, oh, look at the sunshine, I feel, and you automatically, instinctively smile. And as I mentioned in my time in the mountains, I've kind of noticed that kia seem to behave in such a way that it would be similar to that. So we are trying to find sort of environmental correlates of joy, but also trying to work out whether or not it really is kind of a positive emotion. I mean, I tend to use emotion slightly differently from mood. To me, the word joy is a short emotion that is usually event-driven, so it's driven by some kind of stimulus, either seeing the sun or, oh, I got a free bar of chocolate, or I won lotto, or whatever. Whereas a mood, you can still have a positive mood. It's just a longer-lasting thing that seems to be a little more stable and a bit less spiky, if you like. And we want to see that if these emotions are also kind of driving decisions as they do in humans. So emotions drive decisions as do moods drive decisions in humans. It's well established that a lot of economic decisions that are made by humans that are not very rational are driven by moods. In fact, as far as I'm aware, Nobel Prizes have been won on that. And so we want to see whether or not, for example, kia might interpret something as a glass half full versus a glass half empty, depending on whether or not, for example, it's heard a warble call.
So, having identified something that looks like it elicits a positive emotion in kia, this is that equally tricky second part, testing whether this positive emotion affects their decision-making.
The idea being, if you play a kia warble call and you present it with some sort of ambiguous stimulus, like a glass with half of a glass full of water, does it approach it very quickly compared to a kia that might have heard a different type of call that isn't necessarily going to put it in a good mood? So you can train kia, for example, to go to, I don't know, a bowl that is red and has lots and lots of food or really yummy food, and a bowl that's yellow and has not very nice food and really uninteresting food. And then it associates yellow with not a good reward and red with a very good reward. What happens if you show it an orange bowl? And
Gotcha. Our glass half full kia will be like, yeah, orange bowl, it's going to be yum.
Yeah.
And the glass half empty will be,
yeah, that looks like yellow to me. Exactly. And so you can theoretically manipulate, before you present that orange bowl to the kia, you can theoretically manipulate how it's feeling by playing it a warble call, or have it watch a video of other kia playing versus one that is, I don't know, watching a video of kia sitting morosely in a tree when it's raining, or hearing some other kind of call which is not associated with play. And so you could potentially manipulate how it is when it starts that test. Is it in a grumpy mood or is it in a positive mood?
and so at the moment, this is a theoretical kind of experimental setup that you'd need to have to investigate mood.
Yeah, I mean, it's been done on quite lots of animals. There's quite a lot of variation in how successful it is. So some animals require quite a lot of training. Some stimuli are more effective than others. Colors might be better for some animals. Sounds might be better for some animals. So there's a lot of variation, and it's quite difficult sometimes to interpret that. We have tried it with the kia willowbank with moderate success. So we're trying to redesign the experiment right now to see whether or not we can have a better outcome next time.
Willowbank is a wildlife reserve in Old Tautahi, Christchurch, and Ximena has been working with them to develop this next round of experiments with captive kia that they can train. But it takes a lot of careful thought and time to set up this experiment in a way that gives a clear answer. As Ximena said, these kinds of studies have been done with other animals, including the giggling rats. The story of one of these experiments gives an indication of how tricky it can be.
Here what they did is they trained the rats on a certain tone, like at 2000 hertz, for example, and with that they got a reward, and with another one at, say, 9000 hertz, they got some sort of punishment. And then you give them the actual test, And here they presented them with a mid-range tone, so it was 5,000 hertz. And they wondered whether or not the rats were going to be positive or negative in terms of approaching that 5,000 hertz. So they had to pre-prepare before the rats went into the test, them being either handled, just held in hands, something not necessarily aversive but not necessarily pleasurable for the rat either, or belly rubbed. Tickled is what they often refer to it as, which it seems like the rats really enjoy. And so they did this experiment. They had their two groups, the tickled versus the handled rats, and they found that there was no difference overall in how frequently they went or how quickly they approached the ambiguous tone of 5,000 hertz. And so if they'd left it there, they would have gone, well, this was a failed judgment bias experiment, and something like that could have happened to our Kia. And then they went back and they'd video recorded everything, and as well as recorded with an ultrasonic microphone, all the tests. And what they found is when they went to the recordings, some of the tickled rats actually produced these ultrasonic vocalizations and other ones didn't. Possibly they had big rat brothers that over-tickled them when they were too young or something. They hated it. But either way, when they divided that into the rats that produced the USVs versus those that didn't produce the USVs, the ones that did laugh, let's say, did actually approach that ambiguous tone quickly. And so they were optimistic. But if they'd simply just sort of lumped it as tickled versus handled, they would have had no indication that the experiment had actually worked. It just depended on individual variation in the rats about whether or not they enjoyed being belly rubbed.
So, with some redesign, they hope to continue the experiments in Willowbank and further afield.
Hope to replicate that with a group in Willowbank. And there's another actually group of captive Kia in Austria, of all places. And we hope to replicate it in Austria, where they've got quite a large group of captive Kia. So the hope is to be able to get a decent sample size and see whether or not we can retest that.
Yep. There's a group in Austria researching Kia cognition and behaviour at a research station about an hour outside of Vienna. The history of Kia in Austria goes back as far as 1907, when the Emperor of Austria did a trade, some Kia for some alpine chamois. But back to Ximena. Why, I ask, research positive emotions in animals?
The study of negative emotion in animals has been looked at for very obvious reasons for quite some time. So obviously it's got some significant welfare implications, it's got ethical implications, and nobody likes seeing an animal in pain. It's horrible. But positive emotions has been largely overlooked, partly because it was much more important early on to sort out the negative emotions, which potentially can kill an animal. So there hasn't been a whole lot of emphasis on that until more recently, when I think technology has enabled us, such as these ultrasound microphones or, in fact, cameras, thermal cameras that you can point at, for example, eyeballs, which could dilate and contract. The pupils can dilate and contract, and you can actually measure the temperature of the eye, which might reflect how much blood is flowing in the head, which might be a reflection. In fact, it is a reflection of emotion. And so with these sorts of things, I think we can get at it. Why do it? Now that it's feasible to do, I think it's important to try and actually get past the notion that maybe humans are the only animals that might have the capacity to feel joy. And one of the problems with this, and it can face a few obstacles, is that it takes us off the pedestal a little bit. And if we accept that animals are capable of feeling joy and pleasure, it kind of gives some sort of intrinsic value to their lives, which might be an uncomfortable truth to face up to.
Does it also allow for a future where animal welfare is not just looking at a lack of pain, but actually that you're able to set up conditions and scenarios where you have joyful animals?
That's what I'd like to see, yeah. So I think that once we can master some indicators of positive animal emotion in key species that we might, for example, have as domesticated species, if we can reliably measure, for example, eyeball dilation or eyeball temperature with a positive affect, shall we say, then we can potentially design ways in which we can keep our animals in, for example, enclosures that have got better enrichment that will allow the animals to not just not suffer, which is kind of currently a little bit what it's like, but actually to enjoy, to have the capacity to lead a fairly fulfilled life. And some might argue that it's never going to be fulfilled if it's not wild, and there's some merit to that argument, but of course they also, when animals are in the wild, they also have a lot of pain and suffering. They get killed, they get attacked, they get mauled and not necessarily died. They die of cold, they fall off cliffs. So it's not like the wild is all rainbows and unicorns. So we do have to bear that in mind as well. But yeah, my ideal would be to have some kind of world in which if we do have domesticated animals, which are used for whatever reason they're used for, that they are kept in such a way that the animal is not just coping, it's doing well.
If we did learn that animals experience joy, if we could measure it, would it change how we keep them in zoos, in reserves, in aviaries, in yards? Would it change how we think about the animals that we farm and keep? Would it change how we eat? Given her other areas of study, I've got one last question for Professor Ximena Nelson.
Do you ever think of the spiders?
In terms of emotions? I've been asked that before. It's got to be said that I struggle with that one. Even though I'm pretty open-minded, I do struggle with the idea of a happy spider. Mind you, there are spiders that it's tempting to say they're grumpy. Certainly there are spiders that on some days are extremely uncooperative and really unhelpful and just behave in a really not normal manner, and clearly don't want to have anything to do with you. Or I typically move them around with paintbrushes. It's a really easy way of moving them around. And sometimes they get really angry and they'll bite the paintbrush, which is hilarious. And so you do get spiders that can be quite placid, and you can have the same spider that can be quite placid one day and the next day is not having none of it. So, you want to do an experiment and it's like, nah, I've had it. I'm not doing an experiment today. I'm going to jump out of here every single time you try and put me in. So the spiders are not like they're all the same, for sure. And it's not like one day is necessarily going to be the same as the next day. There's quite a lot of evidence now that spiders might have personalities, which would mean that they have enduring kind of traits like boldness or veracity or, risk aversion or whatever it might be, that do tend to be maintained over time. But I still struggle to think of the joyful spider, to be honest.
Thanks to Professor Ximena Nelson from the University of Canterbury te whare wāngana o Waitaha. Ko Claire Kincannon ho te kaiho tū o tēnei hōtaka I āwhina mai a Liz Garton, rawa ko Ellen Rikers. Sound engineering was by Phil Bench, and Tim Watkin is executive producer of podcasts and series at RNZ. Our website is at rnz.co.nz/ourchangingworld. And you can sign up to our monthly newsletter there, and you can also access the extensive back catalogue of Our Changing Worlds episodes, including one where Ximena speaks about her work with jumping spiders. You can also find us on Twitter or Facebook, where we are at RNZ Science. Have you caught up with the latest season of Black Sheep yet? This multi-award-winning podcast is in its 7th season, and the latest episode tells the story of Dr. Alfred Newman, one of the most notorious scientific racists in New Zealand history. While some of his views make for really challenging listening, it's also a really thought-provoking dive into the wider story of scientific racism in Aotearoa at the time. All delivered in William Ray's sound-rich and thoroughly engaging style. Find it on the RNZ website or on whatever podcast app you like to use. Tēnā koe I whakarongo mai. Thanks so much for listening. Have a great week. Kia pai tō wiki.